Your good name? You are Mr. Khalif. Okay. Can you join with him? Okay. We have another friend, Khalif, here. Okay. Let's continue with our class. Can you all see the slide? Components, building components.
Yes.
I started with building components because we are going to see scaffolding, right? We already finished form work, right? Before this, you want to see the champions of last class? A quick one. Easy. I can show you the one on 13/7, right? We finished the quizzes on 13/7. Oh, we didn't have that day, right? We didn't have that day. So no
We have
quizzes.
quiz today, right, teacher?
Yeah, today we got today, but you cooperate. Huh? I try to complete. I got 2 quizzes to complete. Let's see how many I can do it today. Can you all see the slides?
Yes.
So all the sections
Yes.
yesterday I explained how are the sections designed, how are the moment of inertia or the basic value of inertia is calculated, and then it is used for different purposes. It might be for scaffolding, it might be for construction of the building, or as a reinforcement, or other. If it is a steel structure, it will form the part of the structure like beam, column. All the elements are built through these types of sections. Okay. Concrete structures. Let us understand something about concrete structures so that when you go for scaffolding, it will be clear what you are doing. These are the different types. And see the shapes. It is like a semicircular, rectangular, again semicircular. So there are many different types of buildings you will be constructing, right? And then this, see here, a flower type. Flower type. See the foldings, how cleverly you have to bend the beams and the reinforcement so that you can have the required shape done. You cannot see in this one. You can join because I needed data. You can see. And see here, bridge type. This is a bridge with a semicircular member supporting the bridge. It may be concrete structure constructed at the site or precast. Okay, it may be precast. There is another chapter on precast you will study about. Normally, it will be offered as a separate module in every courses, but I don't know. Here you don't have. Anyway, I will complete some of the pre-structure requirements and how it is made, prepared at the site or of the site. Okay, we will have some a little information about this, but that is not the scope of study. But try to understand that the concrete can be made in situ or concrete can be precast. See here the steel members is how cleverly they bend the steel members to prepare the trusses, right? This roof truss is bent to have a nice canopy, nice view, right? Nice landscaping. They will make in different shapes and structures. And see here another type, a dome type. All the members and these crossbars and the long bars. We call later you will understand what are the members there. When you go for steel structures. So for now you just understand this is a long horizontal member, vertical member, and they all bend to form a dome-like structure. And see here this is a form work. You are seeing a form work which is built for construction of a high-rise building, and this is also form work done for construction of building. Composite structure. So we also had a video on composite structure, how composite structure is used for your form work, right? With the PVC and steel. You are seeing here member called, it's a precast supply PVC. I suppose it's a PVC sitting on a steel, right? PVC is used as a border slab for the slab material only. Below this is supported by a beam, a runner beam using steel structure. Sometimes it may be hanging like this, sometimes it may be in this format, in this form. Here you see here concrete structure with a different shape, right? Concrete structure with the pier, and that is supporting the roadway, right? Slabs. Let's understand about the slab. A concrete slab is a common structure element of modern building. Reinforced concrete slab is one of the most important component in a building. It is structural element of, it's not a modern building, for every building. Slab is the most common and prior requirement for any type of construction. It may be a room, it may be a big workshop, or shop lot, or it may be of any type of building, right? Slab forms a horizontal surface, a broad surface for flooring and also for roofing. Right. Slabs are supported on columns and beams, right? Depending on the level it may be supported by columns and beams and then transfer the load to the foundation. RCC slabs whose thickness ranges from 10 to 50 centimeter. 10 to 50 centimeter. Can you imagine? Maybe a foot plus. This is 10 centimeter, half a foot, nearing half a foot, and this may be 1.5 foot, right? 1.5 foot. 30 centimeter is a 1 foot, right? So about 1.5 or less, more than that is the thickness of the slab. Can you imagine 50 centimeter? It may go up to 50 centimeter. It will sometimes it will follow the thickness of the beam. Sometimes it will be less than the thickness of the beam. It's all depending on the structure and the design. Thin concrete slabs are also used for exterior paving purpose, right? Thin slabs as a portico slab, right? Portico roof or just a veranda. So these are all less loading, covering only the loading of the lateral loading of the vein or the people moving in and out. That may be slim or less than the main roof and main flooring structure. Slabs are classified with respect to reinforcement design, construction, and shape design. Mainly they are classified based on their design, whether it's a reinforced or non-reinforced. Construction, what type of construction is a precast or in situ. Shape design, different shapes, different types of design. You cannot have the same monotonous design for all tests because different shapes needs different type of bar bending, different type of materials used to get the required shape. Start with reinforcement design. It may be one-way slab or two-way slab. It is also following the reinforcement design is not only reinforcement design. If I say this one reinforcement design in turn is following the type of loading, type of failure, whether this is going to fail in one way, the member you're going to design for a particular location or particular element of the structure, whether it's going to fail in one way or two way. One way failure means it is just if it is the beam, this is the beam, it will bend in this direction only. If this is the beam, it will bend in this direction only, right? Sometimes it may be two way, it will bend in this direction. If I take the cut section of the slab, it will bend in this direction as well as in the perpendicular to the board, perpendicular to the slide. In both way, horizontal and perpendicular to the slide also, it will bend. So it is a two-way action. Then it needs to be care to be taken to avoid such type of loading by properly designing it as either as a one way or two way. Later you will study all about these type of structures, one way or two way. But depending on the failure, depending on the load type it is taking, you can go for either one way or two way. One way has the structural strength of shortest direction. Moment of resisted in short direction. Longer panel over shorter panel. Yeah. How do you classify the one way? When length to breadth ratio is greater than 2, right? Length to breadth ratio is greater than 2. That means what? Longer panel and shorter panel. And then this may be a rectangular, say it is a rectangular. A two-way has structural strength in two directions. Moment is resisted in both direction. I mean, it can take up the load in both direction, or failure is susceptible for in both direction. That's why the member has to resist in both direction. Draw the slab. Longer length to B will be L over B will be less than 2. L over B will be less than 2. In what occasion? When L is more than. Can you give me an example where L is more or higher in this case? Wait, I take the pen. L over, you can have a short calculation. In this case, L over B is greater than 2, right? Greater than or equal to 2, right? And this should be higher. Length should be higher in this case, so that B is smaller. When length is higher, L will be always greater than 2, isn't it? L is more, it will be always greater than 2, correct? First case, L should be higher, more than, length should be more than the breadth. Yes, then it will be always greater than the 2. Second case, two-way slab, length to breadth ratio is less than 2. That means what? This is higher. B is higher. Breadth is higher than length. Isn't it? Breadth is higher than the length. Then it is always, the ratio will be always less than 2. Correct? I repeat, in first case, one-way slab, length will be more than the breadth. Correct? Length will be more than the breadth. If this is 0.5, this will be 1. If this is 1, this will be 2, something like that. So this is greater than, and I mean L is greater than, where is the, L is always greater than the breadth in one way. In this case, L will be smaller, that's why less than 2. L will be smaller than the breadth, then it is called two-way slab. Okay, so remember these points. It's a quick calculation to say depending on the shape. It is not the only factor, right? It will be based on your analysis, your structural analysis, right? You will subject to structural analysis through either StatPro, Revit, right? You put in this member frame into the. Huh? Are you following? The slide is seen. Yeah, I will not disturb you here after I have people here. Escorts here. I'm so happy. Okay, slide is seen. My voice is here. Don't worry. So this classification we can have quickly to decide, but not only this doesn't. This alone cannot decide whether it's one way or two way. Load, what type of load coming in, what type of structure it is, will decide whether it is a one way or two way. Bear in mind. This will be dictated by your analysis. Don't worry if you go for analysis later on. I think there are many courses and CPP courses conducted by our Mr. Taga, Dr. Ramesh, right? You can attend all those things. You will know how these slabs are designed. These slabs could be cantilever or simply supported slabs. Anytime. Later you will go for, this is your, if you're attending for first semester, you will not know about this. But there are different types of beams, simply supported, cantilever, fixed beam, hanging beam, what else? Hinged beam, many are there. Cantilever means only one side support. You can take the good example as a portico beam. The beam constructed for a portico, beam constructed for a, the one a lintel beam. All are supported on one side, the other side is free, right? Okay. And then if you want, I can draw and show you cantilever beam for semester 1 people. The support will be like this. Okay, the support will be like this. The beam will be standing like this. Okay, so there is a chance of loading, right? If you load, if it is uniformly distributed on the diagram on the over the beam is good. But if it is a concentrated load all acting at this point, there is a sagging movement. Sagging failure will be like this. So you need to address these types of, this is called cantilever beam. This type of beams are called cantilever beam. You have to design according to the type of beam. Simply supported means the beams are supported at both ends, just kept on the support. You can see just the member is like this. The support is on both sides. The support is on both sides. The member is like this, right? Or the support may be like this. So you saw it, not this one. This is fixed support. Not this one. Simply supported means it's like this, just kept on it. Yeah, remember, you can say the, if you go to park garden, you can see the slabs, right? Sit outs, the bench. Bench is the good example for simply supported beam. The support is like this, two supports. The beam will be sitting like this, just kept over, right? Just kept on it, center to center, like end of this one. Not move over, don't mind the drawing. So support will be like this, just supporting at the ends, as though it is just kept on the, as though it is just kept on the support. Okay, so chances of bending will be in this direction. Okay, chances of bending will be in this direction. Okay, later you will study about these types of beams and the failures, and their designs will follow. For now, understand how they are used for different types of slabs. That's all. Okay, any questions so far? No question.
No, miss.
You can also type in the message box. If you have, later I will clarify you. Now coming to the dimensions, it will be showing length and breadth. Just now we are talking about. It will have, you just take the cross section, you will know the length and breadth. If it is a rectangular, square, circular, hexagonal, conical, all types you can take the cross section to know whether it is L to B is more or less than 2. Construction. A concrete slab can be cast in two ways. It could either be prefabricated or cast in situ. Cast in situ means at site. Situ means site. It will be constructed at site. Otherwise, it will be precasted, prefabricated in the company, supplied to the site. Care should be taken. Let's see what are the advantage and disadvantage. Prefabricated concrete slabs are cast in factory and then transported to the site ready to be lowered into place between steel or concrete beams. Okay, all these blocks, sometimes it may be a wall, it may be a beam, it may be a window, it may be any type of opening, right? Construction, they will build at all the blocks are built either reinforced or no reinforcement with all the measurements and design following the drawing. The factory and the machineries will be used at the factory. They use the machineries to build this one and then brought to the site. After all proper curing, reaching the strength, then they're bringing the blocks and the precast materials to the site. In situ or built on the building site using formwork. What is formwork? What is
Temporary
formwork?
structure.
Temporary structure, which is the form which forms the beams and columns or elements of the building for construction. It is constructed at the site. Okay, good. Temporary structure used for construction of building elements at the site and are removed after settling or after the concrete reach the strength. Okay, formwork is a box-like setup in which concrete is poured for the construction of slabs. For reinforcement concrete slabs, reinforcing steel bars are placed within the formwork and then concrete is poured. Yeah, because it is in situ construction, you should place the reinforcement, proper the layer, proper preparation for the surfaces, preparation for the whole structure need to be done, properly clean, and then pour the concrete, right? All these things are following the procedure. Care should be taken for giving the proper cover, proper time for curing, proper time for preparing and placing the concrete. These are all the ingenious things that you have to bear in mind. You should not leave the concrete, after mixing, you should not leave the concrete for long and then start pouring. You should immediately pour it, prepare it before it gets hardened outside. Slabs, it's like this, you can see like this. I will show different pictures later on to understand more about these types. For now, you see here, this is the concrete slab, okay, concrete slab, and these are the reinforcement, okay, these are the reinforcement, slab insulation, right? And then this is tubing, these are the tubings. Tubing, you see, it's a steel, steel, mostly it is steel. And then this is wire mesh. Wire mesh, this is main and this is secondary, that's why its the diameter is less than this one. This may be main, bigger diameter, this may be secondary beam, that's why it is secondary reinforcement, that's why it is less. When you go for RCC design, you will study all about this. Okay, and very important thing you are seeing here, maybe I bigger the size.
Miss, what is
you
the
join
PX tubing?
want to keep annotation discuss. One moment, sir. Say again.
What is the PX tubing? That tube.
Okay. One moment. 105 only. What happened to others? One moment, sir. I'll come back to the slide. Is here, right? Is it here?
Yeah. Yes.
PEX, right? It's a type of tubing used as fiber. It's a type of material, fiber material. I think it's a fiber material, not of steel. I am wrongly given. PEX is a type of polymer used as a reinforcement material here. Okay.
Oh,
I don't remember the full form, but it's a polymer. It's the name of the polymer which is used for construction of these main rods.
Oh, so the function is same as the steel, right? So, prevent the tensile stress.
Yeah, they would have checked the. When you are trying to use the polymer, other type of fiber reinforcement, you should check the strength according to the design. If it is matching, if it is satisfied, If the strength is achieved, you can replace with fibers. This is a type of fiber, polymer. Not, they are not using the steel bar, they are using the PVX polymer here. Still you can use it. Okay.
Okay.
But the cross ones are steel. It seems it's steel. They mix with because these are all costing less. It's only diameter is less, right? They mix with both PVC and then the polymer and the steel. Okay. These are different types of reinforcement. Okay, coming to this one, I want to show you in a bigger dimension. Then you will understand. These pictures I already have. Other pictures also there, but let me show in this. Okay. Here you are seeing the reinforcement. Can you imagine what type of structure it is? Where they are? They are the ground only. Okay. Now what type of structure it is? It might be
slab.
Slab for what? Maybe for flooring, because they are all on the ground
Flooring.
level. Flooring. They are all. It seems they are all at the ground level. Might be a flooring. Okay. Please listen here. What are these you are seeing? These are the reinforcement. Okay. For preparing the floor. For they are doing the in situ concreting for slab. Here you are seeing all the main rods, right? I mean the main beam. Maybe they see the diameter. This should be the going up, right? This is the main. This is the secondary beam, right? Based on the design, you will get number of beams, the spacing of the main rod, spacing of the secondary or auxiliary rods, and then you see here one important gentleman is here. Who are they? Can you imagine? What is this? Why they put these stones here? Can you see the stones? Can you see the stones?
Yes.
What's the
Yes.
purpose? Or what do you call this as? I think I told you in the last class. What are they? These people are like you buy pizza, they put some plastic head, you know. Have you seen in pizza? I think one time I bought in Taman Corner. On pizza, they put a plastic stand inside so that the cover is not touching the pizza. I will show you tomorrow. Sometimes it is that. What is this one? Cover. This is called cover. Okay. Acting as a cover for your reinforcement. Listen, if the cover is not there, right, the steel will be sticking to the bottom. This is the formwork. The bottommost one is the formwork. Okay, the one steel. I think they are using the steel material. Look like steel. The brown one is the formwork, right? The formwork and the steel reinforcement should be separated by the cover like this, like 5 centimeter or 5 to 10 centimeter they maintain. It is equivalent to the height of the cover. They keep this cover and then pour the concrete so that when you finish it, the reinforcement is not seen outside, right? When you finish your concreting, either slab or beam or column, the reinforcement should be inside. It should not be protruding out. So when it is seen outside, you know the effects, right? It will get eroded because there is a rain there. I mean, quite often we get raining. Due to rain, due to other effects, it will get eroded, causing problem to the structure. It will collapse. It will due course of time, it will even collapse the structure. It will leave space for honeycomb, right? Honeycomb, blowholes, all types of problems will raise later on. To avoid it, to have a smooth finish and keep the reinforcement inside the member where it should be, right? The member should hold the reinforcement inside, not outside. To avoid such thing or to get a complete finish of a member, they use these covers. I'll show in other pictures also, it's very clear. They put these covers, then they pour the concrete, okay? Because of these covers, it will fill up the concrete. So now, I mean, after setting everything, if you remove this cover, if you remove this formwork, the concrete will be there after the reinforcement to the thickness of the cover, meaning it is closing the reinforcement and keeping it in good shape and complete. Okay, that's important. Always when I work inside, I always whenever there's a concrete, I have to go around and check all the covers whether they are in position or not. We place it today, tomorrow the people keep on moving on the reinforcement. chances of moving out, right? Chances of coming out of the position. Care should be taken, maybe bay wise, and like 3 meter, 3 meter, they will check all the covers, then start pouring the concrete. And sometimes this type of vibration they use, right? The vibrator they use, they level the concrete, that can also disturb the cover. So care should be taken always to check whether the covers are in position so that you will have complete finish. Otherwise your steel will be protruding out or no concrete at the steel area. Okay. Flood slab. Sometimes slabs will be like this with the capital on top. See here. These are different types only. Flat slabs can be something like this with all the columns supported by decks, one first deck, second deck. And you can see here maybe a parking lot, maybe a parking lot.
Miss, where is the bin?
Where is the beam? Beam.
Yeah.
It is good question. It is fully supported by column here. No beam. The complete load is transferred to the column and the column is transferring the load. There is no beam here. Sometimes I cannot say that it is fully no beam. Sometimes the beam thickness is equivalent to the slab thickness. That's what I said. Depending on the load type, the beam will be equivalent to the size of the column, or it may be more. Usually beam will be more. Okay, because these n beams and columns are going to have more loading than this part, isn't it? So what they do, the beam will be resting on the column, and always their thickness and the depth will be very high, higher than the slab, and it is cast together. Okay, so we do know at this point, we do not know whether this beam is there or not. If you say beam is there, it might be the same size as that of the slab. That's why it's closed. Okay. Otherwise, they made fully of slab, right? One slab is loaded onto the columns, many columns, piers like this. Okay. Oh, here also you can see here. We can see clearly only slab. Maybe N beam. These are the N beam. They only have N beam. Okay. This is the beam. You see the drop should be beam. There is no beam in between. Okay. All right. Or one way, they design it as a one-way slab, and the corresponding loading may be due to like what is a one-way condition? Length should be more than the breadth, isn't it? The slab length should be more than the breadth, then you can go for one way. They design it as a one way. The load that is coming in may be due to one direction. Failure is or the failure of the building or failure of the floor or resisting the load needs to be done in one direction only. That's why the beam is not there. Okay. I mean, cross beams are not there, but the N beam is there. Okay. Did I answer your question?
Yes.
Hi. Some more types, waffle slab. Waffle slab. Discuss only I've seen waffle slab. See here, what are they? Different types, different types, because it's concrete technology. If you see many videos and some videos, interesting videos, a bulldozer, heavy bulldozer, how a heavy bulldozer is used for construction of concrete slab, concrete beam, right? It's all very interesting. You would spend time on this, and whenever you get time to want to know more, you can go through these types of videos and training. But for now, understand what are they? Different materials. It's not a plain slab. You see here this type of all corrugated or just designed one, and here also you can see here some designed one. This material is saved, and the portion of the material is saved. Instead of having a continuous thick slab, they design such a way that wherever there is a necessary for loading, they make it as a thicker one, and the inside material is removed. It enhances two things: save money, save material, save. The design good looking. What the good looking and the what do you call landscaping and aesthetic view of the building is improved. And here also these types, see there's a fully removed material is fully removed. It's not a solid slab, but it's a slab with the provision removal of some materials here. Just they provide only slab at the top. Okay. Different types of design. They are cost saving and innovative design. Ribbed or ribbed slab. See here, these types of only these types of only beam, runner beam, beams are there. All the beams, small beams. By reducing the thickness of the slab, they have more number of beams, and even the beams are of different design. See the beams of different design. They want to have a false roof. That's why they provide these type of less. Maybe this is one single story or double story. That's why they can go in for different types like this. If you construct your own house just for a guest house or small purpose, right, utility purpose, not always staying there then and there, you want to stay, means you can have a economic house design, something like this, with a thin slab and more number of beams instead of going for a very high depth slabs. Okay, and then this is the cross section of the beam and the columns and the slab looking like. Building plan, you're seeing the building plan. Structural design, this is called structural design. Later when you go for RCC design, you will learn all these things. A slab, cross-sectional slab will look like this. Reinforcement detailing, this is called reinforcement detailing of the slab. You see here, what is this? I start with 25 centimeters, all same diameter. They use both as the same diameter. Okay, here you are seeing the slab, okay, seeing the slab, and 4 meter, 4 meter, 4 meter. They design such a way that they will have 10 mm at 25 centimeter. Okay, diameter. If we put the 5 like this, in structural design, structural drawing, in structural drawing, if they put like this, I think you would have seen in many of the drawings, 5. If they put 5, it is called a diameter, short form of a diameter. So 10 mm dia at the spacing, this is referring to the spacing at 25 centimeter spacing. 10 mm dia at 25 centimeter spacing, 20 centimeter spacing, and this side also they have 10 mm at 25 centimeter spacing. So both direction they have the same spacing, same diameter. Okay, and this bending and all, it is due to the sagging and hogging effect that you will study later on. The bar bending is different. Reinforcement detailing and bar bending is a separate section. After you learn the structural design, you will know why this is bent like this and this is like this. Okay, in one word I can say the loading at the support will be very high, so it has to resist more. That's why the reinforcement is on top, okay, heavier, and this side less loading, so the reinforcement is bent to the bottom. Okay, and there are many things you have to learn about this deflection, stability, bending, torsion, many are there. One by one you will study depending on the type of structure and the building you are constructing. Columns. So far we discussed about slabs. Now comes the columns. Columns again can be precast or in situ. Defined as a compression member. Okay, in general, if you say beams and columns, if you classify them based on the load bearing, based on the stability, we call column as a compression member, beam as a tension member. Because when you load the beam, it will bend like this, right? Or bend. When you load the member, right? When you load the beam, it will bend like this. So it's elongation, right? This is called as elongation. Elongation means what? Elongation means what? Elongation means what? Length is increased, right? Length is increased.
Yeah, the length is increased.
Elongation, or like you study the Young's modulus and so on, right? It will extend this way. That's why it's called bending. Bending is more, bending member. But when you come to column, when you load the column, it will compress, get compressed like this, get compressed inside. It will in the beam like this. The column will bend like this, push inside. The material is pushed inside, or compression is more. That's why we call always the column as the compression member and beam as the tension member. So you need to design mainly the columns for taking compression load. Check whether the material and the size and shape is bearing the compression load and how much is the value. And then design your column, construct your column. They transmit loads from the upper floors to the lower level and then to the foundation, right? So as you keep on increasing the floors all the loads coming over, right, needs to be calculated based on the number of floors. So the bottommost one will be the biggest size. As you go on, the column size will be keep on reducing because the overcoming load is getting reduced as you go up, as you increase in levels of the floor. Okay. Column classification: shape, slenderness ratio, type of loading, pattern of lateral reinforcement. Right, these are the criteria based on which you can classify. Slabs also classified on 3 types, right? Remember those slab classification: reinforcement design, construction, and shape design. Slabs are classified under these 3 categories based on the reinforcement, whether one way or two way, construction, in situ or precast, shape design, right? What type of shape is it, and then what type of aesthetic is improved, or material, based on the material also they classify. Column will be based on shape, slenderness. You will see what is slenderness ratio. This ratio determines the type of design, and type of loading, pattern of lateral reinforcement. We'll see what is lateral reinforcement first. Column. A column may be classified based on different criteria, such as depending on the shape. Number 1 is the shape. Based on the shape, it may be rectangular, square, circular. Have you ever seen any other type on your way home, on the road, or your home nearby your home, or when you go for a tour? What type? What type? What shape is it? Shape. We're talking about the shape. Semicircular. Rectangular, square. Yeah, you would have seen. Yeah, yes, you say you have seen, right? Yeah, of course. So my question is, it's written the common shapes, right? Rectangular, square, circular. I'm asking, have you ever seen other than these shapes? It goes by the cross section. Nowhere. You're talking about column, right? Just think of conical, water tank. What about water tank? Water tank and fountain, all built like a conical shape, right? It's also standing on a column. Am I correct? Conical shape. But common shapes are this thing, and you can find this thing in your code book. That's why they limit with this. But due to technology development, right, you may have any type, for example, conical shape, hexagonal shape, pentagon shape, they're out there. Just cut the section and see, that's all, right? The shapes may be varying, not limited to these 3, but here it is limited due to the code book, your manuals code book, steel code book, or concrete code book, whatever it is, they will be classifying based on these 3 types. Okay, you're seeing the reinforcement here. And then circular, right? Circular column, rectangular, square. Maybe this one is a square because based on the reinforcement, it seems it's a square column. Okay, following. Based on slenderness ratio. What is slenderness ratio? Why they didn't give the ratio here? Okay, anyway, short column, a slenderness ratio, or otherwise a short column or a long column. The ratio determines whether the column is a short column or long column. Short column will be less than 10. The ratio of the slenderness ratio will be less than 10 for short column, more than 10 for long column. Okay, we will do this calculation when you go for design, actual design. Length to breadth ratio, again here it's a cross section by height, a number of, there are different types of calculation, but mainly cross section by the depth here, because you have square, circular, rectangular, right? So they will have a ratio, and if the ratio is less than 10, short column. If the ratio is greater than 10, long column, right? Based on type of loading, axial loading column, a column subject to axial load and uniaxial bending, a column subject to axial load and biaxial bending. See, number 1 is short column, axial loaded column. All columns will be, short columns will be subjected to only axial load. Axial means along the axis, right? Axial load, if you say, if the column is like this, right? I took the pin. So axial loading means at the center, my hand is checking. at the center. The loading is transferred like this. Biaxial loading. Second one, one moment. Second one is subject to axial load and uniaxial bending. As the length of the column increases, it will become a cantilever beam. It looks like a cantilever beam. Am I correct? Just now I explained what is cantilever beam, right? Supported at one end, right? The other end is free. Am I correct? When you are constructing columns, right? When you are constructing columns, especially the columns for a water tank, columns for a bridge, right? Be a bridge or any other type. Hanging, there are some garden type flyover, construction for flyover. If you take initially, it looks like a cantilever beam, right? Supported to the ground. As it grows in height, it looks like a cantilever beam. Hence, it will no longer subject to only axial load. It will also have other types of failure, which is bending. It acts as a beam. That's why it will have both compression and bending. So I'm not going to explain about this analysis part, but understand that there are types like for short columns, this is limited to axial loading. For long columns or very highest columns for high-rise buildings, then water tanks, especially water tanks which is to be stored at very high height for getting pressure, or any structures used for hydropower generation, or whatever is at very high height, will undergo both axial loading and bending. In that case, you have to design it as a for both load. Okay, for both load. Then columns subjected to axial load and biaxial loading. Bear in mind. Coming to this type, steel columns, steel column, right? Here the steel column, maybe they are constructing a workshop. They are constructing workshop. We call this as a girder. Girder. The section is I section girder, and then this is the column, and this is the column with wooden panels, wooden roof. So you are seeing here columns based on pattern and lateral reinforcement. Yes, it can be classified based on the lateral reinforcement. Tied columns, spiral columns. Okay, there are two types you can see here. Tied columns, all ties connectors, and then sometimes it is maybe a spiral column. Come on, let's see this one. You can see here the reinforcement is just the horizontal, and this is the main and this is the secondary, the horizontal and vertical. You are seeing this as a plan view. This is column, right? This is elevation view, this is plan view. Elevation view, plan view. Okay, tie column means these members are called tie members. Tie. So two vertical reinforcements are connected by many ties. If you do it like this, it's called tie member. This is looking in the elevation view, this is plan view. Plan view, you can see here, this is the main one, the corner bars, right? The corner bars, and there's a wire which is going around. The corners, you can see the black one, right? Wait, I increase the size. It's got bigger the size so that I can explain clearly. Okay, but I have other pictures, don't worry. I'll show you. See, this rod is represented by the points over there. That is called main rod. This is the column, reinforcement all around. And these are the things you are seeing in the plan view. This and this and this one. And then the connector or the secondary bar, which is acting as a tie member, just tie member, is called as this point, these things. Okay, these things that the spacing also you will design. This spacing also you will design. So it is like a box type, covering all the four rods. This one, two, and other side, perpendicular to the slide. You can see other two bars on the other side at distance, maybe at distance of this one. Okay, so all these four bars are connected or put together, hold together, forming a reinforcement by these types of ties. Okay, that is called tie reinforcement. And the other one, the same type, instead of having a square or rectangular type, it may be spiral like this. Spiral, manufacturing is easier. There are some advantages going for this one. Instead of having a secondary bars at distance, they just make it as a spiral, so that all the main reinforcement are kept in position, and you can pour your concrete. Okay, so based on the structure also, it can be defined as spiral columns or tied columns. This is most common, and tied columns are most common. This may be due to developments and due to cost saving they have come out with. And there are dangers and there are failures. I don't go much into details now. Later we'll discuss about this. But proper concreting should be done in both cases. Proper cover, proper curing should be done to attain its strength. Okay. Beams. Coming to the beams, we saw slab, column, now beams. Okay. Finish this part. Time, right? Because I want to run the quiz after I finish this building and go for scaffolding. Is that okay? Because I want to do part by. Okay. Beams take up the low compressive and add rigidity to the structure. Beams generally carry vertical gravitational forces, but can also be used to carry horizontal loads due to an earthquake or wind. Okay, when you see when you load a member beam, when you load a beam, say simply supported beam like this, it is supported like this, right? The failure section may be, I use the other color. The failure section may be something like this. The bad color, blue. The failure may be like this, okay? And if it is a member, I mean, say for example, it's a beam, and this is the thickness of the beam, okay? Thickness of the beam. You can see here, this portion is more towards compression, okay? More towards compression. And this portion, the failure, if you talk about the failure, and this is the pen. This portion is elongated, right? I can take this as a tension. I cannot write tension, right? The bottom portion of the beam is elongated. The inner portion is compressed, isn't it? Right? That's why I'm saying beam take up compressive and add rigidity to the structure. What the beam is supposed to be doing? I take this beam shape is like this, red color, right? Originally the beam is like this, right? The beam of this thickness, right? When it is loaded, it tends to bend this direction, right? This is one type, this is tension, and this is compression, right? So it needs to take both loading. Accordingly, you will supply the reinforcement to resist. This member have to resist the load that is coming in, so that this is not bending or this is kept in position. Always the structure is safe all through its service period, right? This type of failure have to be avoided. Okay, doing so, what is written here? Let me take the laser. So beam have to support the structure rigidly, bearing both type of load and also lateral load. Here it is written, it can also take lateral load based on the support. These are mostly fixed support. I'm just explaining you with respect to simply supported so that it's clear at first look. Also used to carry horizontal loads. Sometimes it is supposed to take horizontal loads. It may be a wind load, it may be earthquake load. All these types have to be included while designing the beam. Now, types of beam. Coming to the types of beam. Number one is type of loading, right? Whatever. Type of loading. Number two, types of reinforcement. It may be RCC beam or it may be steel beam. RCC beam are cast in cement concrete reinforced with steel bars. Okay, just now we saw the reinforcements, right? And they like this type. All these things are RCC beam because reinforcement is there. Steel beam means like this solid type. Mostly the workshops, right? Steel structure, trusses, cranes, where the cranes are operated, where the loading, unloading, processing center, manufacturing center, all types of steel structure. If the workshop is fully constructed using steel members, then they will go for these types of steel. They no longer use the precast or reinforced one. Because it's cost effective, stronger, stronger than RCC. Okay. Where is it? RCC beam or steel beam like this. So you see here a solid member, a solid steel member of different cross section. It may be I section, rectangular section, circular section, any type. Right. The reinforcement may be singly reinforcement, doubly reinforcement, depending on whether it has to take like the failure. Remember this failure. Doubly reinforcement means if you want to take the if you want to design the member to take compression and reinforcement, put reinforcement at the top and also bottom. If the member is supposed to take only tension, put the reinforcement only at the bottom. You will study about all these things later on, but for now understand whether it is singly reinforced or doubly reinforced. Okay, it's only the matter whether it's put both direction or only one direction. I'll show some examples later. Here also you can see. Okay. Oh, just now I explained. It's already here. RCC beam, singly reinforced and doubly reinforced. So you see here. Just now I show you the picture, right? Top member. Top member is a compression. Bottom member is subjected to tension loading. That's what written here. So this member is designed only for this beam, singly reinforced, because the reinforcement is found at the bottom only. This is the support, and this member is designed as a singly reinforced because you can see the steel bar only at the bottom to take only tensile load. And the cross section, cut section of the member, if you cut the beam at this point, okay, cut and see the view, you can see the structure like this. Okay, this member, projected view of this rods, right, reinforcement, and there is no rods here. That's why it's called as singly reinforced. And then doubly reinforced will be looking like this. Then I show. Oh, it's here. There's a point. Doubly reinforced will be something like this. See, bottom. It's a beam or column. It's not clear here. Maybe I show here. The cross section will look like this. You will have the blue line here also, just like this. Another line here. Then it is called doubly reinforced. The top member will take up the compression. Top reinforcement will take the compression. Bottom reinforcement will take the tension. This is what I want to show you before. Covers, these are all called covers to have complete finishing and to avoid these reinforcement protruding out or seen out of the concrete or exposed to outside air and water or any other type of environmental changes, to avoid these types of materials subjected to changes, degrading quality and spoiling later on. You should completely check for the cover and then go for concreting. Sometimes here you are using the stones. Mostly I have seen the gravel stones are used, right, of regular shape. They will collect and use it. Otherwise, you can see here the plastics, small plastics. Plastics are used as a cover. Okay, it is nicely done. All fixing. See the bars are tightly closed and there are overlaps also. You can see some overlaps. You should avoid such overlaps because it may be over designing or a problem for your concreting. I mean, not much. You have to know how much is it. They're all bar bending details. The bar benders will do. The engineers will only check how much is the length, diameter is maintained or not, spacing is maintained or not. Covers are there. Covers also they have a spacing. You have to put it at this spacing. It can also follow the form work, right? Okay. Beams. Steel beams will look like this. It will have a cross section. Hollow beams. You are seeing a hollow beam. One beam, this is a whole beam I section, but they have inside the call. Even this material is removed. It's not a fully solid member. It's a hollow member. It may be like this, a plywood I section. Last slide on building elements, rebar arrangement. Okay, it's a continuous beam. If you take any roof, any building top roof, we call that as continuous beam because the beams are continuous. It's not one beam. It will run for about 10 meter, 20 meter for the whole span of the building. It has to run. Then it is called as continuous beam. It will have intermittent support, right? It will have intermittent support. The beam is continuing. Analysis is different, and the designs and the reinforcements are something similar to this one. An example one is shown here. Number 1 span. Okay, number 1 span. And number 2 span. Is there the cross section you cannot see here? Okay. This one, when you check, These are the reinforcement, these are the reinforcement detail, reinforcement. This is the thickness of the beam, right? Thickness of the beam, this is column, right? You will do this part later and don't have to worry, but have an idea about how the drawing will look like. This is called reinforcement detailing, okay? It will have the size of the beam, the reinforcement, whether top and bottom or only at the bottom, and this is called crack. They provide purposely a groove like structure. Later you will know what is it. And then what else? That's all you need to learn from this one, just for an give an idea about how the final sketches, final detailing will be looking like. Okay, I stop here. Finishing I will do later. If you all plastering lah, what plastic material, what are the plastic material, what mortar you are going to use, steel mortar or painting, all these things are there. We will do it. I hope you can manage with this. Let me go for quizzes now, right? Quizzes. We'll come back and do the scaffolding. We have half an hour now. Can we go for quizzes now? Are you ready?
Sorry, miss.
Are you ready for quiz now? Quiz on building components.
Sorry, miss.
Yes. Yes.
Okay.
Oh.
I'll be conducting 2 quizzes today. I want to complete the number 1 quiz, building component. Okay. The question on building components now. It will take 5 minutes only, hardly 5 to 10. If you join faster, hardly 5 minutes we use it. Okay. Please do it. Wait, how many? 108. What happened to remaining 6 people missing today? Wait, I open the quizzes.com. Quick one, eh? Any question while I join opening the slides?
Yes, miss, I have a question.
Please.
In detailing, those diagrams, are they always the same or do they change? Because I'm doing RC and it happens that all the diagrams seem the same for me.
You are doing RCC module.
RC1.
Okay.
Yeah.
What do you mean all same? What do you mean all are same?
Yes. All of the diagram examples, they all have this structure. Maybe they might have another column, but they pretty much always have the same structure and these formulas. So I was wondering if you just get the length, let's say L1, and you substitute into 0.L1, and then you just place values just like that, and you're done.
No, drawing, you are right. As the sketch will be same. All sketches will have the size of the beam, size of the rod, position of the rod, position of the main rod, position of the means size of the main rod, size of the secondary bar, and the cover. Overall sketch will be same, but the values will be varying.
Okay, so if I have L1, I just place into 0.1 L1 and I calculate what's the value, I put it there, and I do the same for everything, and it's done.
Yeah, the sketch is similar.
Okay.
Only the sizing, spacing also you design. Spacing also you design one after another. What are the main rod spacing, secondary rod spacing, and number of the rods, and then what else? Size, mainly the size, and then beam size. Beam size also changing, column size also changing. Well, the sketch will be same. All will have the same detailing. You should have the size of the beam, reinforcement detailing, mainly the size and the spacing and the cover and all these things. Okay.
Thank you.
Come on, where are we? Your one moment. I share the slide for you. You can join. You know the website, right? I type here. Join my. My quizzes. Today I start with the building. I prepare all, but unfortunately I cannot run any of them. This is a building component. Done. Building component. Play live. Continue. Let me share the slide for you. Just a break, like a break and recall what you study. Can you see the code? Join myquiz.com. Can you see the code? Khalid,
Yes.
I have two people here, like two pillars. I am excited to see you all, but no, only two people turn up today. Yeah, I open. Take photo. Okay. Thank you. One zero four join. Very good. Very fast. Good. I start now. Okay, I start now. 108 already there. Your attendance also 108. I think. Let me start. Still joining. Okay, start.
If you're finished, teacher, can we leave?
Let's continue. We have let's say option. I have to continue with the next topic.
We can't hear you.
One more.
Done, miss.
One moment. All of you have done. Questions for EP? I stop here.
अच्छा सर ठंडा है
Interesting. You can see the one, winners. You can see, right? You can see or not? Okay. One moment. Let me share the result quickly. Let me share the results. You can see the results. Our toppers in building components just now. Xia Yun Jung, Tanzi Hao, Ko Jin Wen. Ko Jin Wen. Friends. Good. And other champions, and there are some more. 10 champions. Tanzi Hao, Xiao Jun, Ku Jing, Li Ju, Khalif Ali. Nee, dear. Wow, he's here. Good. Khalif Ali, Muhammad, congrats. Hishma Solihi, Wang Ka Fei, Wang Wai Zun, Bandran, Tarshini, Marwan, Gozan. Okay. Very good attempt. Special congrats to Tanzi Hao. I quite often see this name. Good. Keep it up. All of you should get all answers correct, because just immediately after your class. Right, let's continue with the next topic. Let me share the slide. Quick one, the scaffolding. But I cannot make it quick. Let me try. Let me try. Save. One moment, I take the scaffolding. An important topic for you. I try to complete, otherwise we will see after all your presentation done. I see how much I can complete. Huh? What? Next week. We are starting presentation next week, right? We are starting presentation next week. Are you clear with the presentation detailing everything? Prepare your slides, come prepared. Like this, you all assemble, come online. Like I'm talking, that day you will be talking one after another, right? One after another, quickly be ready with microphone and video. You have to switch on your camera and also audio. I have to see your face, otherwise no marking. So everyone be prepared with your camera and okay, Kan, okay, any difficulty? That day only I'm going to see you people. Oh, this is awesome. This is Khalif. This is one voice soon. Surprising classes. Don't surprise me too much. Okay, you have to on your camera and microphone. Clear? Yeah, I will give permission to share one by one. Others mute. I open for you, the particular person, one after another. I will organize. I open a channel. I will tell you, explain you. That's so quite comfortable. No problem. With MS thing is possible. We do it. We can, but come prepared, very clear with what you're going to say. Few lines only, 3 minutes. Just like that, it will go. All right. Come on. Let me start with the slide. Scaffolding, an important topic, very interesting topic. Some mechanics involved. Be alert in this evening. Some mechanics and tools and table parts are elements are there. Okay. What is formwork? All of you know what is formwork, right? All of you know what is formwork. Okay. Formwork is the thing that the structures, shutters, the boxes that are used for making your concrete, preparing your concrete column slab. A temporary structure for, scaffolding will be the poles, all the supporting elements of formwork are called as scaffolding. It may be vertical, it may be horizontal, it may be inclined, it may be a screw, nut, bolt, tie, pin. All these things are called as scaffolding elements. Okay. Today we are going to see, so far we study only the formwork, the boxes that are used for temporary structures used for making your concrete and in situ. Now we are going to see how this form works at some height, right? At some height, it is not at lower ground. Any elements that are constructed more than 1.5 meter high have to be supported safely so that people can go in and make it, prepare it, pour the concrete, make the concrete, right? Or prepare the reinforcement, everything done on the site. For this purpose, you need to support this formwork by a means of what is called scaffolding. Temporary structures for persons can gain access to the place in order to carry out their building operation. So access to the place means formwork, access to the formwork in order to carry out their building operation. All the supporting elements used for formwork is called scaffolding. A temporary framework usually constructed from steel or aluminum, wood, alloy, tubes, clipped or coupled together to provide a means of access to the high-level working areas as well as providing a safe platform from which they can work, right? So they are all working at height, isn't it? If you see some of the videos, they are all hanging and working. That's why all these laborers and construction people, they are all working at the cost of their life. Sometimes they're just hanging and doing. If it is a offshore work, if the structure is into the water, they're just having only the footrest. I will show you the videos. Very dangerous and hazardous, the risky jobs they are doing. They just stand on a pole, just a pole or a footrest, do their formwork, do the concreting, do any type of fixing and organizing, constructing or dismantling work. Okay, and another thing, these formworks and these scaffoldings are used not only for construction, it may be used for demolition, monitoring, maintenance, repair work, right? If there is any part of the slab have to be removed beside, they will support the building first for renovation, especially for renovation. They will support all the slabs and then they go for renovation of the slab beside or the same slab. Okay, these scaffoldings are not only used for construction, they are also used for renovation, repair, monitoring, maintenance. All these types of jobs are done using this temporary structure. A temporary framework usually constructed, all this done, right? Materials, it can be wood, alloy, polymer, or aluminum, metal, steel, any type. Here you are seeing, these are the form, all the blue lines you are seeing are called formwork, because the building is being raised and the people have to go reach to the top to do their components. See, so one by one, then they have to build their walls here, columns to be extended, beams have to be costed, and so on, right? So these framework, these temporary structures, it might be steel or wood, but mostly it is steel because high rise, right? It has to withstand the loading. So they use the steel rods, steel pipes, steel timber, steel columns and beams to construct this with the toe board. We'll see one by one. This is another type of scaffolding, another type of scaffolding or supporting structures to build structure. as the height is increasing above and above. What are the primary elements? I have a pictures also. Don't worry, we will explain one by one. Number one is a standard. You have time, right? 6:30. Standards, ledgers, putlock, right? Putlock or putlock, we can say couplers, transform. What is the meaning is transform. Braces, bridle, guardrail, toe board, rackers. Give me another 5-10 minutes. Standards. Standards will be all these main, the main rod, the first pole that they are used for construction of this scaffolding is called standards, and the crossbars are called as crossbars. I will tell the crossbars later. And this, see here, the points and the square, small squares. The small squares you're seeing here. These are the standards. These are the ledgers. Okay, these are all called ledgers. This horizontal one and the side ones are called ledgers. This one, side one. So main members are called column type, column-like structures are called as standards, and the columns are connected by ledgers to form a box. It may be a box, or it may be a circle. It may be of any type and shape. Okay, and then putlocks are this one. Putlocks are the members and just wooden member. Okay, this picture will help you to understand what is putlock. Putlock is here. See here, this one. These gentlemen are called putlocks. This is standard. This is ledger. Okay, I repeat. This is standard. This is ledger, and the putlocks are the wooden member which is just kept on the structure. One will be into the wall. Another one will be into the scaffolding. I repeat, put logs. Log means wooden piece. It's like a wooden piece, wooden board. One portion will be inside the building, another portion will be onto the scaffolding. You see here, the scaffolding got the standard and the ledgers. These are the ledgers. Laser pointer. These are the ledgers. These are the standards. These are the putlocks. These are the putlocks. Putlocks are always one side onto the wall, another side onto the standards. Transforms. Transforms will be here. These are the putlocks, again called as a putlocks, but they both ends are supported on the ledgers. See here, both ends, and these are the putlocks. These are putlocks. Both ends are onto the scaffolding. Braces. Braces, they are a diagonal crossing pieces fixed at the standard. See, these are the braces. Braces may be panel by panel or all together. The cross braces. Cross braces, diagonals, diagonals are called braces. The braces are connecting the standards. Okay, it may be all together or panel by panel they build. So the cross members or connectors between the standards are called, especially diagonal members are called bracings. Horizontal also there, but mostly they are connecting standards and ledgers. Bridle. Bridle will be, I'll show you the bridle here. Bridle will be this one, the number 6. Number 6 is called bridle. Bridle is the slab, it's a board, wooden log or wooden board, which is kept on the putlocks. These are the putlocks. These are the putlocks. Onto the putlock, the boards are there. The people will stand here and do the construction. The man will stand here and do the construction. It's like a toe board, but they call this as a bridle. Bridle will be kept onto the putlocks. These are the putlocks. Okay. Guard rails. Guard rails are these one. All the rails supporting the board, toe board. All these guard rails. So horizontal boards where man is standing here. The man is standing here. Guard rails they can hold and do it. That's why it's called guard rails. Rails means is a runner wherein they can support, they can hold and stand here. These are called guard rails, and this is toe board. This is toe board. Okay. Later you go through one by one, but I am giving you quickly the position of different elements. And these are the rackers. Sometimes as the height is going on, there may be chances of bending, right? It's looking like a cantilever beam, supported here and free here. So to avoid bending, any type of bending this direction, rackers are provided, and they are firm into the rigidity is by means of the ground. They put into the ground, or sometimes the sill plates are there. We will see one by one. There's a nice video. Play now. I stop here. Okay. I can continue. One moment. Let me stop here because I don't drag it too much. We will continue next class. Maybe after all presentation done, I will continue with one more class and the revision. Okay. In one class, I finish this and also try to do the revision for you. Okay. We will have online assessment. It is not exam. Online assessment. I will give you the topics to master in so that you are ready for the exam. Is that clear? It's not exam, assessment, online assessment. 24 hours or 12 hours will be given to you to complete that particular assessment, mostly of case study. I stop here. Any question you can ask me.
When will the assessment time start?
Plan to have by 15th week. Let me. Did you get the timetable? Timetable, exam timetable.
Timetable of what?
No.
You don't have. Okay, I will ask for the exam timetable. It will have the dates.
The duration is like 17 until 30th of August.
15th week, right? 16th week. We finish classes 15th week, 14th week, 15th week will be break and starts from 16th week, you'll have exams, right? Yeah, we follow those days only. If I get a tentative exam timetable, I pass to you. I check with the faculty, Dr. Rozaima. Okay? Any other question? Come prepare for presentation next week. Yeah, well, listen to me. You have to wisely use your time. 3 minutes means have to follow. Discipline yourself to present only 3 minutes. Don't disturb any other. Present and stop. Close your mic and camera. Let the other go on. Okay? Because the individual.
The presentation is on 27, right, teacher?
Next.
27.
Next week, right?
Okay.
Next week, right? Wait, let me take the date for you. It's on 20. This is already 11th week, right? Next week is 20 and 20. We start on 20.
So the presentation is on 20th.
Yeah, 20 next Monday. Starting on next Monday. Follow the time schedule given to you. It is already there under the section assessment section. You go to the assessment channel, you can find it. If not, I will post again in CN so that you can have the timetable for you. Please be available at that time. If you miss it, you lost your 20 marks already. Follow the timing. Be discipline yourself to attend within the given time and not disturbing others. You can answer the Q&A later on. Others are allowed to ask question, but you can type in the chat box and this will be answered. Just put the name like Ryan is presenting. Ryan, just give the question. Brian, you want to ask question to Brian? Brian, then type the question. Q&A is not written time, but you are still allowed to ask question. Just type in the chat box. All will be answered to you later on. Okay? To manage the time and planning this.
Those who do not present also need to attend on that day, right?
Yes. All have to be online. Only the man who is presenting is given permission to on camera and microphone. One after another, I give the permission.
The final exam is online?
Yes.
Okay.
Any other question?
Hi, Miss.
No,
I can't
thank you, Miss.
Yeah, thank you.
Miss,
Bye-bye.
I still can't find my name on the presentation schedule.
What's your name?
Brandon.
Yeah, I added already. You check?
Oh,
You check
okay,
now?
okay.
Under the
All right,
files.
thank you, Miss.
Yeah, it's added. If you want to type
Miss,
again for
where
the
can you find the presentation schedule? Where can I find it?
wait, I share for you this one. Can you see the main MS team now? Yes. You can see, right? MS team. Can you see the channel I'm opening? Can you see the channel? Can you all see the channel, general and theme presentation? You can see, right? Come on. You can see
No.
theme presentation? No.
Now we see the slides.
Just see the slide.
Oh, slide. Wait, I close this one. I share first. I'll show you where it is. One moment. I close this and share with this one. I'm here. MS team. Can you see here? MS team, huh? Can you see the channels? One moment. Just can you see the team? Meeting team? Okay. In that, if you go to team, can you see the channel on the left hand side? General, theme presentation, 2 channels. These are all called channels. Below the name, the icon, this is the icon for your team. The name of the EEV 413, BEV 1053. Can you see? All of you can see? And 2 channels for the
Yes.
generally it's for all class. If you click this, you will have all classes, all classes, all our regular classes, timing, questions, chart during class time. This is like classroom. And this channel is exclusively made for your presentation. Okay, presentation, assessment. No, I put it separately. Assignment, I will put another channel so that it's not confusing. It is for quick access only. So this theme presentation, if you click, you will have all these things. And number 1, see, I posted, and this one is a theme presentation schedule, right? And this one, rubrics, and this one slide submission. Wait, I posted the slide. This one is slide submission. If you click, you can submit your slide. Okay. And files, if you want files, all the files are stored here. Related to theme presentation, all files are stored here. Go to files on top, you can see all the files. Similarly, if you go to general, if you go to files, you will see all your class materials. Class material assessment I need to remove because I put a separate section already. It is blank. Quizzes only, because to avoid any competition between people, I didn't put many quizzes inside. Anyway, I will remove this one later on. But under files, what you have to follow? One moment, I click again. Under files, you have to follow class materials. Under class materials, you have all these class notes up to date. Up to date means last week, until last week. Monday and today I will post it over this weekend. Until last week, all the videos, revision, tutorials, all are here. Okay. When the revision also I posted here. And this one, files, go to general. You can see videos also. Some of the webinars, videos also I posted here. All right, clear?
Miss,
Mm.
I'm trying to open the presentation schedule, but it gave me like expired. I can't open it.
Schedule? How come it's expired? Are you see? I open.
Bro, try another time. It was like that for me too, but the second time it worked.
Yeah, it is like open online. Click on the open. See here, open online, right? You can download also. You can download, right? You can download. You can open online. Did you try both of them? Can you see? Are you seeing the cursor moving on the theme presentation? Let me open online. For me, it should be opening because I already access login and password. At this point, it may ask for your login and password of your UCSI. So you need to type in. See, it's open already. Just now Badran was asking, right? Then you put Badran here. Brandon, 109. Brandon, you're already here. Plug in 61 and 65. Brandon is here. Not here. Okay, his schedule is already there. So I have put for all these 114 students. They are all good. All are here. Okay, you can open like this. Can you see the slide? I mean the schedule just now I opened?
No, miss.
No.
No.
Wait, I open once again and share for you. I need to share. When I open, I got this slide, okay? One moment, I shared that one. I got this one. When you open, you will get this one. Can you see?
Yes.
Open online or download and you will get it, no problem. And slides, try to upload it, okay? So that you don't do any last minute work. You are safe and you are well planned. You're not doing many assessment in my case, right? In this module. So be well planned, properly use the time, don't delay, don't block others' timing. It is very close, one after another. Okay, thank you so much. See you next class.
Thank you.
Miss,
Any other question? Last question. Yeah, please. What do you want?
Miss, I have a question.
Hmm.
Miss, there will be an assignment assessment, right?
There is an assignment I didn't post yet. Please give me time.
Oh,
Maybe tomorrow I post to you and give you 2 weeks time.
okay.
Question and
Miss.
answer. I give you 2 weeks time. Don't worry. All question and answer, like a paragraph type or mostly paragraph type. Calculation won't be there because we never do any calculation. All theory, all the like factors, elements, requirements, and then some of the technologies I will include. Okay, in the questions.
Okay, thank you, Miss.
Any other question?
Miss.
Yes.
You put the wrong title for my one.
Yeah, title.
Can I change it back?
Yeah, you go. See, you go here. You go here. You change. Wait, I show you. You have to change it. Wait, I show you. I share the slide with you. Where is it? When I go to this part, okay, you can see the. One moment. Let me go there. All of you can change your slide by going into. Go to the theme. Can you see the theme presentation? Channels
Yeah.
you can see, right? Under this, go to file. Go to file and then click on these titles. Can you see the name theme presentation title?
Yeah.
Right? Open this file. Conveniently,
So I
you
can-
edit for. Yeah, you edit your file here. What's your name?
Michael.
Michael. You find your
62,
name.
I think.
Okay. Go here. I just minimize this. Go to Michael and then do it. Okay.
Okay.
Go to Michael and edit your files, theme presentation, 62.
2.
Nice here. Drawn in construction. You want to change, you edit it. I given permission to all to edit, but don't disturb others. I request everyone, please don't disturb others. There may be changes. You are welcome to edit. This is where you have to edit your title. Keep it correct. All right. I will follow this title for you marking.
But Miss, my title is the number 63 one.
All
You
one jump.
misplaced it, I think.
Michael is following this one 63 tragedy.
Yeah. Yeah.
Is this the case for everyone? I jump one. Wait, let me do it right now. One moment. It's not minimizing. Let me do it right now. I'm afraid if somebody have to. Abdi is here. Abdi, by chance, Abdi is here. Abdi is here. Abdi Yasir is here. Is this your title? Better I don't shift it right now. Some of you already corrected. I request all of you to correct it here. Spend 1 minute to correct it here. Okay? I repeat, it is parked under Teams channel. The channel is the channel is theme presentation. Click on the theme presentation. Go to files. You will find your Excel sheet. Open the Excel sheet and do your editing for your title. Okay.
Miss,
Yes.
already I changed the title of my topic, but still I see my old topic.
How come it's not changed? It's online. You don't need to save even. If you don't mind, can you do it today and check tomorrow? It should be correct.
Yeah, I'm number 2.
Abdullahi.
Yeah.
What title is it?
Already I sent you in chat. Then you say change yourself. Already I changed it, but still I see my.
Yeah, what's your title?
Yeah, it's dam construction.
All about dam construction. Good one. If I put it capital, dam construction. Like this, you please change it. Anybody else want to change? Just keep it typed and keep in your slide also correct name. All right. It's good you upload all your slides by this week. Easy for you. Be well prepared beforehand. Just use 3 to 5 slides enough. Not much. One slide for 1 minute.
Miss,
Yes.
Can I do the correction on my name? Because
what name?
My name is Sun Jun An at 42. My own name. Yeah, but here writes Jun An Sun.
Yeah, please follow this name. This is what available in IAS, right? It's their mistake. Sorry, I should not complain. The thing is, it is what written in IAS. I follow exactly the same. Since I put your name here, just follow for now. I have arranged in alphabetical order. It's easy for me to cross check later on.
Okay.
Help me, but all the words are correct, right? June and June, right?
Yeah, correct.
Thank you.
Just the arrangement are not correct.
Joseph, can you please type your title? Joseph Julius, please type your title. It's blank here, as though you are not attending class. Hey, Joseph, any other name is new to me. One word is missing. Okay, I will find out. Can you all keep it updated so that easy for later reference and marking also convenient for me? I don't have to run between slides and this. Okay. Okay. Any other question? I'll continue and then after all presentation done, because I want to follow the schedule. Do you have any question? Ask him what content he's going to talk. Ask him by message or by chat group. You are there, right? No, title. Yeah, title may be the same, right? Wait, let me stop this at recording. You can ask him, because I don't know how it's overlapping. There are chances. That's why I put it together so that you know what your friend is doing. You call him, text him or message him. Otherwise, I will also help you to do. Ask him whether this is. Stop recording. Good. Thank you. Thank you for showing your face. How you did? Oh, open the camera. Hey, you can open the camera.